Welcome to the class of medical physics. Why physics is necessary in medicine? Have you ever wondered why physics is important in the field of medicine? Well, there are numerous reasons why it is so much vital, so much important to the field of medicine. Physics is present in everything from the workings of accurate medical scale to the imaging equipments like X-rays, MRI, ultrasound, etc. And that's because it becomes actually pretty much hard to give a simple answer because there is so much of physics in medicine. It's hard to know where to start. A simple answer is that physics is useful across many aspects of medicine, both in treatment but more in diagnostic aspects. Diagnostic medicines like x-rays, ct scans, ultrasound, and much more are there that we deal or we study in medical physics. Another reason of the knowledge of physics is important for medicine is that it is a branch of applied physics that uses principles of physics, methods, and technique for the prevention, diagnosis, and treatment of human diseases with a specific goal for improving human health and well being. It generally concerns physics as applied to medical imaging and radiotherapy. Medical imaging refers to the techniques and processes used to create images of human body in the form of for the diagnosis purpose or examine of diseases to visualize what disturbance has been caused or what abnormal function is happening within the body. So scanning of all those images come in radiology section. An MRI scan, diagnostic radiology, and X-rays, fluoroscopy, mammography, angiography, and CT scans all are the technologies which are using in modern medicine are complemented due to the physics. So, physics can be very useful to understand the underlying science behind all these technologies of modern science, that what makes them work, their mechanism, working mechanism, and their applications, and all that. So, you see, physics is a great help in the field of medicine, and without it, we are not able to enjoy what we are enjoying today in terms of treating our diseases and serving the well being. So, in this subject, we are going to cover or we are going to familiarize students with different medical physics specialities for diagnosis and therapy of diseases. We want to create an ability in our graduate students to gain knowledge in medical physics independently. Further, to disseminate the knowledge of medical physics in order to improve the health care, diagnosis, and therapeutic medicines and methods in medicine. So, here are again the main areas of medical physics which we are going to cover, or for those areas, we are going to cover the theory, basic theory behind physics. In diagnostic radiology, we have ultrasound techniques, MRI, computed tomography, X rays, fluoroscopy. In terms of radiotherapy or the treatment purposes, we use linear accelerator, LAs, cobalt 60, and much more. Likewise, in nuclear medicine, we have radioisotopes for the treatment purpose, for diagnostic purpose. and few of them are PET scans, SPECT, and chemotherapy like techniques. So, moving ahead towards the course content, for the basic aspects of physics to be covered before going towards the hardcore content of medical physics, we have to learn the basics of electricity and magnetism, sound waves, heat, the main part, electromagnetic radiation, and a very, very important parts of safety in biomedical instrument, and radiation protection. So the first topic is electricity and magnetism. In both electricity and magnetism, we need to learn first about the electron concept, the electron theory about that, what is behind the main and the very basic part of human survival or the universe, that is electron, the very, very, very basic element. So, electron theory states that all matter is comprised of molecules, which in turn are comprised of atoms, which are again comprised of proton, neutron, their subunits. If I say so, proton, neutron, electrons are all the subunits of atom, and the molecule is the smallest part of atom which can be exit by itself and contains one or more atom. So, as you all know, the human body is composed of, or the basic element of human body we consider is cell. Cell comprises, or when cell made up the tissues, tissues made up the organs, and organ made up the whole system of human body. ठीक है? Whole system and then our human body. So, as cell is the basic unit of human body, likewise, the whole universe is consist of two basic things, that is mass and energy. The whole universe is made up of mass and energy. The mass itself is what? The mass itself is present in the form of matter. And we all know that in physics, we do study and we do have idea about that. Matters, we usually deal or we usually study the three types of matters, that is solid, liquid, and gases. But there is one other kind, that is plasma. We don't deal that plasma infrequent. So all three states of matters comprises of the basic, or stands on the basic element, that is atom. Atom itself is comprises of the basic subunits, those are proton, neutron, and electron. So this is the structure of matter. We have, if we go the subdivisions of matter, we will find the molecule. If we further go into the detail, we have atom and then elementary particles. So what is the structure of atom? Atom comprises of proton, neutrons, and electrons, as we have discussed. Structure of atom being proposed in 400 BC at the time of early Indian and Greek philosophers. It is a fundamental building block of every matter, or the basic unit of every element. Atom consists of three basic particles, protons, electrons, and neutrons, within which neutrons and protons are present in at the center of the atom, which is called the nucleus, and the proton is by default, by nature, has a positive electrical charge, whereas neutron sustain no charge at all. It is a neutral element. However, the outermost region of the atom are called Regions of the outermost atom are called the orbital shell, and electrons revolve, survive, or stay into those orbitals and shells. Next is what happens or what about the countings of those electron, protons, and neutrons. You must be know that the number of electrons and number of protons in any stable natural element atom are equal, and due to their equivalency of positive and negative charges, atom behaves as electrically neutral particle. However, if number of electrons will increase somehow to the number of protons, the atom will behave as a negatively charged particle, and it will called as acceptor atom. If the atom has capacity to accept the ion, that particular element is known as the acceptor atom. Whereas if an atom has capacity or capability to donate its electron, and there is found an imbalance in the number of electrons and number of protons, that atom is known as or become a positively charged atom and called a donor atom. I repeat, by default, the number of electrons and number of protons in any atom will remain same. Here are few key terms related to the topic. The first one is mass number. Mass number is the total sum of number of protons and number of neutrons found in an atom. Okay. Next is the atomic number. The number of protons in an atom are called the atomic number. Again, I repeat, neutral atoms of element contain an equal number of protons and equal number of neutrons. So if an atom is neutral, so you can also say that if an atom is at its neutral state, so you can say that the number of protons is number of electrons is equal to number of is called the atomic number. But as number of electrons can be varied, it could be increased or decreased depending upon whether the atom is accepting the electron or donating it. We do not stick to the definition. The atomic number is the number of electron, and we remind it as the total number of protons because the number of protons do never alter. So in this figure, there is an example of carbon element. If you see the number, there is a 6 written, which is known as the atomic number, and the 12 is denoting the mass number. It indicates that in carbon element, the number of protons and number of neutrons are both 6, because this 6 of atomic number is denoting the number of proton. So 12 minus 6 will give you the result of number of neutrons. So 12 minus 6 is also equal to 6, which means the number of neutrons in carbon is also 6. Whereas this one is showing you the isotope of carbon. What are isotopes? Isotopes are atoms of the same element that contain an identical number of protons but a different number of neutrons. In nature, we do have elements whose isotopes exist naturally, but those isotopes of elements do not found at high percentage, but in a very least amount they are present. And the identity of those isotopes is that they are varied in terms of their number of neutrons only. Number of protons will remain same. Next is energy level orbits. Both are one and the same terms. Energy levels, also called electron shells, are fixed distance from nucleus of an atom where electrons may be found. Okay. So in order to understand the energy level or the orbit of electrons, it is easy to recall or assume the case of staircase. Okay. Energy levels are like the steps of a staircase. Like you can stand on one step at a time or another step at another time, but you cannot stand within between the steps. So, similarly, electrons can occupy one energy level, or electrons can stay in one energy level at a time, but cannot stay in between those energy gaps or energy levels. There is a void in between them. There is no nothing. If you see, there are four energy orbitals in this figure, that is K, L, M, and N. Each energy level or orbital has different energies. The energy level 1 has the least amount of energy, means the electrons found in that energy level have least amount of energy, whereas the energy level 2 will have a little more amount of energy. Energy level 3 will have further more amount of energy, and likewise it goes on. Another thing is that each energy level can occupy, can withstand only a limited amount or limited number of electrons within it. The first energy level, which has the least amount of energy, can only bear 2 electrons at a time, not more than that. Likewise, the second orbital can hold 8 electrons. The third one have will have 18 capacity of electrons, and then 32. So what is the arrangement of holding all those electrons? The question is that. So let me explain you. There is a formula to calculate or fill up those electrons in energy orbitals. That formula is 2n raised to the power n square, where n represents the energy level. So when you want to find out that which energy orbital is going to have how many electrons, so you can easily use that formula to find out the capacity. So for energy level 1, you will use 1 at the place of n and put up in the formula. That will give you 2 into 1 is equals to 2. Similarly, if you want to check out for energy level 2, you simply need to you simply need to put 2 over there, and you will get the square of 2 as 4, and then you will find 8 as the answer. So the number of electrons the second orbital can hold is 8. Likewise, for the third orbital, you are supposed to put 3 into that, and you will find 18 as a result. So square of the 3 it will give you 9, and 9, 2 times of 9 will give you 18. So this is very much easy to understand how we are filling up the electrons in any of the orbital. Moving ahead, there is a little note that electrons in energy level 1 have least amount of energy. We have already discussed. And when you go farther from the nucleus, electrons at high levels have more energy, and their energy increases by a fixed discrete amount. The values are discrete. Electrons can jump from a lower to the next higher energy level if they absorb this amount of energy. Conversely, if electrons jump from a higher to a lower energy level, they give off the energy, whereas if they jump from lower to higher energy level, they can jump only if they absorb certain amount of energy. As I told you that the K shell, K orbital is the nearest one from the nucleus, so it has the least amount of energy. So it has been concluded that the electrons which are very much near or very much close to the nucleus are close to the nucleus because they have least amount of energy. They are not having that huge amount of energy that could make them independent, and so that they can jump from lowest energy level to the higher energy level. But as soon as they gain energy, the electrons would become able to jump from lower energy level, and they move on to the higher energy level. And likewise, if an electron can absorb from external environment few more amount of energy, it will jump from K to L and M to N. For example, if an element has only 4 energy orbitals in its structure, so what would happen if an electron is present in its n stage or n orbital, and if it could absorb more energy, what will happen? It will become as independent electron or free electron, and it will come out of the atom, and it will become as a free electron. So how an electron will become a free electron? By absorbing more and more amount of energy. So likewise, if any atom element will lose energy, so their electrons will jump towards the nucleus. I hope this is pretty much clear to you now. Next is electrical conductors. Conductors are the material or substance which allow electricity to flow through them. Electrical conductors, we have two types of conductors, the thermal conductors and the electrical conductors. That's why I have specified here the electrical conductors, because we have thermal conductors as well, which we will discuss in the topic of heat. So electrical conductors are the materials or substance which allow electricity to flow through them. So what is present in that material which are electrical conductors to make them allow to flow the electricity? So that particular element is are free electrons that are found in electrical conductors that allow the conductors to conduct the electricity. So they have free electrons on their inner surfaces or outer surfaces, which allow current to pass through easily. I repeat, free electrons are present both inside surface or the outside surface. That is why when you touch a bare wire, you will feel an obvious shock of electricity, because free electrons are present both inside and outside of the conductor surface. They conduct electricity because the flow of electron, the presence of free electron present inside the conductor will allow the current to flow inside and free electrons move from atom to atoms. It okay. Metal, humans, earth, and animals are all conductors. It provides a resistance free path for current to flow from wire to body. Here are a few examples of conductors. Materials such as silver is the best conductor of electricity, but it is very much costly. So we don't use silver in industries and especially in transmission of electricity because we need a lot amount of conductors for the transmission of electricity throughout the state or country. Copper, brass, steel, gold, and aluminum are all good conductors of electricity. We use them in electric circuits, in power systems, in the form of wires and components. Mercury is excellent liquid conductors. We will have liquid conductors in details in future. Thus, this material find use in many instruments because mercury is an excellent liquid conductor. Gases are not good conductors of electricity, and the reason is that the atoms in gases are found quite far away. Thus, they are unable to conduct electrons. Free electrons are present in gases as well, but their atoms are very much at distant to each other. So the flow cannot be found as free, fluent in gases as compared to the liquid and solids. Applications of conductors. There are quite useful examples of conductors in our daily life. For example, mercury is a common material used in thermometer to find out the temperature of the body. Mercury has a capacity to expand itself and it has free electrons good enough to conduct the but mercury here in thermometer is used as thermal conductor. Aluminium find its use in making foils to store food. It is also used to in the production of fry pans or different crockery items to store heat quickly. Iron is a common material used in vehicle engine manufacturing to conduct heat. The plate of iron is made up of steel to absorb heat briskly. Conductors find their use in car radiators to irradiate heat away from the engine. Next are electrical insulators. Insulators are materials or substance which resist heat and electricity both and do not allow the electrical current or electron flow through them as they do not have that much free electrons as do conductors have. As you can see in this picture right over here, that conductors have so many free electrons, whereas the insulator have a quite or no free electrons near to. So the property which makes insulator different from conductor is its resistivity. Insulators are used as protectors. They give protection against heat, sound, and electricity, of course. Wood, cloth, glass, mica, and quartz are some good examples of insulator applications. I repeat, insulators are very much helpful in our daily life. They resist the flow of electron, that is why they are insulator. The applications of thermal insulator is they disallow heat to move from one place to another. Hence, we use them in making thermoplastic bottles or our water bottles of like thermoflask and all that. They are also used in proving ceilings and walls. Some insulators help in controlling noise level as they are good absorbents of sound. Thus, we use them in buildings and conference hall to make them noise free. However, electrical insulators hinder the flow of electron or passage of current through them, so we use them extensively in circuit boards and high voltage system. They're also used in coating of electric wires and cables. As I told you that free electrons are present in on both surfaces of conductors, the inside and outside surface. So that is why you experience the electric shock when you touch a bare wire. So a coating of insulators is very much needed into that. What are the difference between conductors and insulators? We have so many points before, but here is a quick review. Conductor allow currents to flow easily through it. However, insulator don't allow current to flow through it. Electric charge exists on the surfaces both inside and outside of conductor. However, electric charges are absent in insulators. Conductors do not store energy when kept in a magnetic field. Insulators store energy when kept in a magnetic field. Conductors within magnetic field we will discuss in future. Thermal conductivity allow thermal conductivity of conductors are very high as they are good conductors of heat and electricity, and thermal conductivity of insulators is very low as well. The resistance of conductor is very low, whereas the resistance of insulator is very high. Because the resistance is very low, that is why they are conductors and they can conduct with more capacity. And they are insulators because they insulate or they stops the conductivity because their resistance is very much high. Copper, aluminium, and mercury are some good conductors. Good, they are both good thermal conductors and electrical conductors. However, wood, paper, and ceramic are some insulators. Examples: conductors are used in making electrical equipment. However, insulators are used in insulating electrical equipment for safety purposes. Next, we are going to have our the was the overview of physics. Now we are going to have our first topic as static electricity. What is static electricity? So, what is static electricity? Static electricity is an imbalance of electric charges within or on the surface of material. The charges remains there until they are able to move away by means of electric current or electrical discharge. Static electricity is named in contrast with current electricity which flows through wires or other conductors to transmit energy. Static electricity is sorry. So there are basically in metals and conductors, electrical conductors, we have a fixed arrangement, a specific arrangement of electric charges in any metal. We do have positive charges as well as negative charges and have a neutral stage, a mixed arrangement of both the charges present in metal. So what happens in static electricity is basically if you create a disturbance and imbalance in those electric charges, if you induce a few electric charges into them through the means of conductions, or you disturb the arrangement pattern of those electric charges that generate the static electricity. As the name is indicating, the static, it means there is no flow of electrons, which is actually the current. So that dynamic electricity is the term used for current. So, what is static electricity? Static electricity is that it means that the electricity is there, but it is static. The disturbance or occurring happening over there in this state is due to the disturbance of those neutral electrical arrangements or structure within that material. So that cause or makes the static electricity. Whereas the current electricity is the actual flow of electrical charges or electrons, free electrons through wire or a proper conducting material. And due to that, the energy transfer from one body or one component to another. How does static electricity generate? If two surfaces are rubbed against each other, then both may become charged by friction. As they rub together, electrons from one surface remove and deposited on the surface of other materials, and once there is an imbalance of electrons has created, like one is removing their electron, and that electron is going to be deposited in the material of others on the surface of other material, that creates a vacancy, a vacant position of electron in first material, and an additional presence of electron in the next material. That is basically the disturbance part I am talking about, and that becomes the cause of generating static electricity in both of them. And that is happening because of the friction mechanism. So, since all materials, whether conductors or insulators, are naturally electrical neutral materials, as I told you, all elements and every matter or everything is made up of, is composed of atom. So, atoms are present in both the conductors and insulators similarly. But what is making them different from each other is the presence of free electrons. However, naturally, both the conductors and insulators are electrically neutral because the atoms are present into them. So they are neutral. So, because of course, equal number of protons and neutrons are present into them, that's making them the neutral. So the transfer of electrons leaving from one material with less electron makes it positively charged. Due to that vacant position, a hole is generated in the donor atom or the donor material, while the other who is adopting that coming electron will become the negatively charged material. And as it is an acceptor element, so this rubbing mechanism is making the one as positively charged and the other as negatively charged. So there's a disturbance in the electrically neutral arrangement of the structure of any element, any material, that is making them static electricity that is generating, inducing into them. So here is a diagram showing naturally the both materials, whether they are conductor, whether they are insulators, they are neutral at their own level. No matter what the size is, no matter what the shape is, if you rub them against each other in opposite direction, like it is showing in the figure, it is generating friction among them and making them to the level of it, or gener- uh, making a static electricity, generating a static electricity into them, as one is accepting the electrons and the other one is donating the electron, and become the positively charged material and the negatively charged material. I have an example for you. If you rub plastic rod against a piece of cloth, for example, you can experience, static electricity. We also have one very common example of static electricity in our daily life, which we do experience all the time in winters, especially, or of course in winters, is that when you rub your hair, when you brush your hairs, what happen? You feel a certain amount of attraction of hairs after brushing, that your hairs are attracting towards the brush. What is happening basically? The atoms are present into your hairs as well as into your plastic brush or whatever. So, in winters, what happened? We do have dryness all in our surrounding, and due to that dryness, the moisture is absent. So when you start brushing your hair, what happens? Due to that friction, because due to that friction, the electrons start transferring from one surface to another, and that is making them the one material as positively charged and the another as negatively charged. And the difference in electrical charges make the one object to be attracted towards the other. Your hairs are attracting towards the brush, so it means that they have some attracting mechanism due to the positive and negative charges. So it is a very good example. Next is charging by conduction. Charging by conduction involves the contact of a charged object to a neutral object. What is that? Charging by conduction means you are charging or making any object, any neutral object, an electrical one, or disturbing their neutral arrangement, structural arrangement by coming a conductor that is already in conduction or electrically charged in contact with that neutral object. And when you touch both of them together, what happens? The electrons, which are high in that conducting material, will start transferring into the neutral body, and that makes it charged too. This is your charging by conduction. Hence, when an uncharged conductor is brought in contact with the charged conductor, charge is shared between two conductors, and hence uncharged conductor gets charged. During charging and conduction, both objects acquire the same type of charge. Next is charging by induction. What is the difference between charging by conduction? Induction is the contact of those charging materials. In previous one, we saw that electrical charges are transferring from the charging conductor to the neutral one, whereas charging by induction is showing that the two objects are not in direct contact with each other, but when an electrically charged object is come into the premises of or near to the neutral conductor, what happens? The excess of free electrons or the charges make or disturb the arrangement of neutral conductor. As I told you earlier, that any neutral object contains the both positively charged elements and the negatively charged elements. So, when electrically charged object comes into the premises or surrounding of a neutral object, it will disturbs the internal arrangement of that neutral object, and the positive elements or positive atoms will start adhering or collecting towards the side facing the electrically charged object, and the negative will go to the other side of the object. That disturbance will make that neutral conductor to be no more neutral, and it gets charged. This is your charging by induction. When a charged object is brought near but do not touch a neutral conducting object, the presence of a charged object near a neutral conductor will induce forces or force electron within the conductor to move. So there is no actual or direct transfer of electron from this object to that one, but only the disturbance got affected. And this disturbance also contribute or um, account for static electricity. This movement of electrons leave an imbalance of charge on opposite sides of the neutral conductor while the overall object is neutral by default because of the same number of protons and electrons, of course. So there is an excess of positive charge on one side of the object and excess of negative charge on the opposite side of the object. So this is charging by induction. Next is electrostatic field. Electrostatic field, as you saw, what is happening when electrically charged object comes into in the premises of neutral conductor due to the electric field found around this electrically charged object is inducing or disturbing the arrangement of this conductor or this substance or material, whatever object. The electrical field present or found around this conductor is such forceful that is affecting the internal arrangement of this conductor. So this is what electrostatic fields are. When once an atom which is in neutral state will become a positive charge atom or the negative charge atom, or if it is an object even, we can have both positive charge atom and positive charge object both. I'm talking about both. So when a positive charge atom or object, when a neutral object will become positive charge or negative charge, they have a certain electrostatic field found around those charge or object. The arrowheads are showing the away outlook from positive charge, whereas towards the negative charge means the attraction of positive to negative is found in such a way that positive charge attracts towards the negative one. Negative never get attracts towards a positive one, but a positive one will attract towards the negative one. So that is the reason why I told you the your hairs get attracted towards the brush because one gets positively charged and the other gets negatively charged. So the hairs once get positively charged, they go and attract towards the plastic material of your brush, and the attraction is occurs due to that electrostatic field. So an electrostatic field exists in the region surrounding an electrically charged object. This charged object, when brought in close proximity to an uncharged object, can induce a charge on the formerly neutral object. This is known as induced charge that we saw in charging by induction. So, unlike charges attract each other, whereas like charges repel each other. And this is the reason why like charges repel each other. So, here is a query question. Why does like charges repel each other and so unlike attract each other? We already have discussed somehow these two. Next is the density of lines and patterns. I have three different conditions A, B, and C. Both are positively charged, whether the atom, whether the object, but the arrow lines are very much least in A, then many more in B, and then maximum in C. These all are positively charged because the arrowheads are away from the object. So, what is the difference in all of them? The density of lines and patterns means the intensity of the positiveness present in all three of them. A will have least amount of electrostatic fields, whereas B has more and C has the maximum. The density of electric field lines around these three objects reveals that quantity of charge C is greater than that of B, which is greater than that on A. So, when you once you brought a negative charge into close proximity of A, B, and C, of course, the C will get attracts more than B or A. So this is the density or intensity of those all three elements to get attracted. Next is basic electric components for circuit design. We have a few basic components uh, which are needed or which will be discussed in upcoming future very soon are resistors, capacitors, inductor, diode, LEDs, transistors, ICs, relay, and battery. Next are the first one, capacitor. Capacitor is a storage electrical energy device in okay, it is a device that stores electrical energy in electric field in the form of electric charges. It is a passive electronic component with two terminals. Here is the symbol of capacitor, and the positive and negative sign are showing their terminals. Here are the actual presentation of capacitors you found. So, what does capacitor do? They stores the electrical energy in the form of electrical charges when the electric field is created. Storage of electrical charges in the form of electrostatic fields between the plates. They have two plates arrangement. That is why they are symbolized like this. It consists of at least two electrical conductor plates separated by a dielectric insulator. The conductor can be thin film of metal, aluminum foil, or disc, etc. It does not dissipate energy because it is storing energy. Okay, it is also used in electronic circuits for building direct current while allowing alternating current to pass. A very good application of capacitors are both in DC circuits and AC circuits. In DC circuits, it blocks the direct current. Why does it block? Discuss. We will discuss also, and why it is allowing the alternating current. How does energy is stored in a capacitor? Here is an arrangement of uh, capacitor with the supply, that is battery over here. The red one is showing you the positive plate or the positive electrode of the capacitor. The green one is showing you the negative electrode of the capacitor, and there is a dielectric insulator in between them. When there is a potential difference across the conductor is created through any battery or supply, an electric field develops across the dielectric, causing positive charge to collect on one plate and negative charge to collect on other plate. Why do we use dielectric in between? Because we want, when we make the circuit complete, we want the positive charges to be collected on electrode and negative charges to be collected on electrode so that we can use those collection for future use, as this is a storage device. So if a battery has been attached to a capacitor for a sufficient amount of time, no current can flow through the capacitor, although the circuit is complete, because but a dielectric has been used in between, that which is stopping the flow of current and the storage of charges, of course. Next is the types of capacitor. The different types of capacitors are electrolytic, mica, paper, film, non-polarized, and ceramic. Here are their real time figures. Arrangement of capacitors are in series and parallel. Okay, so this is the symbol. When you draw a circuit diagram, you will draw the capacitor in series like this and the equivalent capacitor. When capacitors are connected in series, the total capacitance is less than any of the series individual capacitance. Why is this so? This is because if two or more capacitors are connected in series, the overall effect is decreased due to increase in plate spacing. You have two capacitors in series, you have one spacing and then the other. So when electrons or flow of current will coming from the supply, it will pass through the C1. There is an accumulation of electron, and the electrons coming after that will be low in amount, and the storage will be less in on C2. So the total capacitance will be decreased. Thus, the total capacitance is less than any one of the individual capacitors' capacitance. And the formula to calculate that total capacitance is as follows: 1 over the inverse of the sum of inverse of individual capacitance. Okay. Next is capacitors in parallel. Here is how you will draw the capacitors in parallel in your circuit diagram. Parallel arrangement. When capacitors are connected in parallel, the total capacitance is the sum of individual capacitors, because you start when you start passing the flow of electrons to that capacitors, the both capacitor will receive the same number of electrons flow, so the storage will remain same, and the equivalent will be the additive sum of both of them. And if you have more than two capacitors in parallel, like C1, C2 plus C3 plus C4, you will get the additive effect of all of them. If two or more capacitors are connected in parallel, the overall effect is increases in plate area, because you have more plates and you are getting the same number of electrons at the same time. So keeping the other factors remain unchanged, the resulting capacitance will be more than that of individual capacitance. Thus, the total capacitance is more than any one of the individual capacitors' capacitance. The formula for calculating the capacitance of capacitors connected in parallel combination is as below. Just add up the capacity of all the capacitor capacitance, and then you will get the total of that. So it has been concluded that capacitance will be diminished when you connected them in series, whereas it will add up when you connected them in parallel. Next is charging and discharging of capacitors. Question number 1 is, explain the polarity of capacitor during charging and discharging. During the process of charging the capacitor, the current flows towards the positive plate and away from the negative plate, while during the discharging capacitor, the current flows away from the positive and towards the negative plate. This is the difference between the charging and the discharging of capacitor. Is the time for charging and discharging of capacitor is equal? Of course not. The process of charging, storage, and discharging, the release of the energy of a capacitor is never instantaneous. It's a prolonged process, but it takes a certain amount of time to occur, with the time taken for capacitor to charge or discharge with a certain percentage of its maximum supply value, which is called time constant. So the charging and discharging time is not equal, as you can also experience this thing in your mobile storage battery. You you have different time in charging up your mobile phone, whereas different time in discharging of your mobile phone. So this is all up to the today's class of static electricity and the brief introduction of physics, the basic physics, and of course, how do we use what we discuss in medical physics, why we are using it, why we are studying it. So that's up for today. Thank you.